First, we select the directory where the data has been saved from the medical system. We select whether we would like to parse data from the left and right hemisphere, from the left hemisphere only, or the right hemisphere only. Now we see the data that is passed from the depth by each electrode. The left anterior electrode is processed depth by depth. We can see those depths. Here we see grayed areas that represent the forbidden amplitudes for the spikes. Here we can see the average shape of the spikes. The whole procedure of parsing is quite a fast one. It only took slightly above 1 minute to complete. Now we can move to computing the statistics. We select the patient, and we can see that for this patient there is only data for the left database, and we select the computation of the spike statistics. This computation takes a very short time, as during the parsing procedure, the spikes have all been detected and sorted. When we complete the spike statistics, we can go to the computation of the background statistics. The background statistics take a bit longer to complete, as the whole dataset has to be processed, not just the spike occurrences. During the calculation of the background attributes, any artifacts that are present in the recording have to be removed. It is quite possible that there are artifacts. As you can see, they can be quite numerous. These artifacts have to be removed prior to computing the background attributes. Without this removal, those attributes would be incorrect. When we have finished calculating both the spike and background attributes, we can pass to the classification. Classification can be done in two ways, in an automatic way or in a manual way. We will choose the automatic classification. Automatic classification is done using the Weka software in the background. We can click this button, and in this moment the data from all attributes, both the spike and background attributes, are passed to Weka. Using the trained classifier, the recordings are classified as to whether the recording given is coming from the STN or not. It has been completed. Here we can choose the patient, the left hemisphere, and now we can see the attributes that have been calculated. And we can see how they changed over the depths as the electrodes passed through the brain. The first attribute is called spike meta power. The anterior electrode is shown in red, the central electrode is shown in green, and the medial electrode is shown in blue. There are 4 spike base attributes. 2 attributes show the spike occurrences per second. This can be shown here for all cells near the electrode, or for the best cell near the electrode. Here is the best ratio. The best ratio is based on the distance between spike occurrences. It is on a scale between 0 and 1. Finally, here is the best ratio for the best cell near the electrode recording tip. The last groups of attributes are background attributes. The first one is the 80th percentile of the amplitude modules. You can see immediately that background-based attributes give a much clearer picture of the results. You can see the area where the structure we are looking for, the subthalamic nucleus, is located. We can see from this picture that this area of high-value attributes is the area where we expect the STN to be. Thank you. This system was developed by Dr. Konrad Ciecierski in his PhD thesis written under the direction of Dr. Zbyszek Ras, voiceover provided by Laurel Powell. Thank you.